Hello, good day everyone. My name is Neil Joseph Hilary Alquinones, and today we'll be discussing about Module 7. Module 7 is all about quartile of the group data. So, first of all, what is a quartile? So, quartile divides the data into four parts, and it contains three values. These three values are called Q1, the lower quartile, Q2, the median, and Q3, the upper quartile. Now, the formulas that will be used in getting Q1, Q2, and Q3. First is for the Q1. Q1 is equals to the lower boundary times n over 4 minus cumulative frequency over frequency of Q1 times the interval. So as you can see, XLB is known as the lower boundary of the Q1 class, n is the total frequency, CFB is the cumulative frequency before the Q1. Frequency, if Q1 is the frequency of Q1, then I is the size of the class interval. Okay, then next is for the Q2. Q2 is equals to the lower boundary plus 2 times the overall frequency over 4 minus the less than cumulative frequency over frequency of Q2 times the class interval. Now, as you can see here, Q1 and Q2 are closely similar. The only difference is that in Q2 there is a 2 being multiplied in the total frequency. Okay, take note of that. Next is for the upper quartile or the Q3. Then the formula for Q3 is also very the same for the Q1 and Q2, but the only difference is that 3 is being multiplied in the total frequency. Now the formula will be lower boundary plus 3 times the total frequency over 4 minus the less than cumulative frequency over frequency of Q3 times the class interval. Now, first, before inputting the data acquired into the formulas, we first need to identify which part of the data is the Q1, the Q2, and the Q3. Now, to get this data, we just need to use the formula for getting the Q1, the Q2, and Q3 of the given data. Now, to identify the Q1, formula that will be used will be n over 4. For Q2, 2n over 4. Now for Q3, it's just 3n over 4. So it's very easy to memorize since Q1 is just equal to n over 4, while Q2 is just n being multiplied by 2 over 4, and Q3 is just equal to 3 being multiplied to the n over 4, where n is equal to the total frequency. Okay? Next will be an example. So, for example number 1, the table shows the daily wages of 50 workers in a private company. So as you can see here, these are the data for the daily wages and the frequency. Now, we need to find the following: the Q1, Q2, and Q3, and the entered quartile range. Okay, now let's proceed to step 1. We first need to get the lower boundary and the cumulative frequency of the data. Now, in getting the lower boundary, you just need to take a look here at the given data of the daily wages or the class interval. Here, you can see that the given lower limit and upper limit here is the 400, are given a lower limit and upper limit. Now, to get the lower boundary, you just need to subtract 0.5 from the lower limit. Now here, you can see in the lower part of the data, 451 is the lower limit and 500 is the upper limit. Now, in order to get the lower boundary, we just need to subtract 0.5 from the 451, which is the lower limit. Then it would be then equal to 450.5. Now that is our lower boundary. So just the same as in the first data given, the second data is the lower limit is 501, then the upper limit is 550. To get the lower boundary, you just need to subtract 0.5 from the lower limit. So 501 minus 0.5 is equals to 500.5. That is our lower boundary. And this goes on until to all the datas. So as you can see, the lower boundary is here already solved. Next is the cumulative frequency. Getting the cumulative frequency is just easy. You just need to add the subsequent frequencies as you go on. Now, for the first frequency, which is equals to 4, is equals to 4. Plus 14, it will then become to 18. Then 18 plus 6, it will then become to 24. Then 24 plus 5, it will equate to 29. 29 plus 9 equals to 38. And last but not least, 38 plus 12 is equals to 50. Now 50 is our total frequency. Okay? So that is just how easy you can get the cumulative frequency. You just need to add the frequencies to get the cumulative frequencies. Okay? So next is step 2. We need to identify where is Q1, Q2, and Q3 located. Now using the formula for locating the Q1, Q2, and Q3, Q1 is equals to N over 4, which is N is the total frequency. And the total frequency is 50. Then 50 over 4 is equals to 12.5. Okay, remember that, 12.5. Next is the Q2. Q2 is just equals to 2N over 4, where N is equals to the total frequency. Then 2 times 50 is equals to 100 over 4 is equals to 25. Then last but not least is the Q3, which is just the 3 times the total frequency over 4. And the total frequency is 50 times 3 divided by 4. It equals to 37.5. Okay, now this is how we're going to locate our Q1, Q2, and Q3. So from the formulas that we used in solving Q1 and Q2 and Q3, we just need to base it in the cumulative frequency. Now for Q1, Q1 is equals to 12.5. As you can see here in the cumulative frequency, there is no 12.5. But 12.5 is somewhere in between 4 and 18. Then all you have to do is, then you will just assume that it belongs here in the second to the last. Here we will just assume that our data for the Q1 is from the daily wages of 501 to 550, which has a frequency of 14 and lower boundary of 550.5. Since Q1 is just equal to 12.5, and it cannot be located here in the cumulative frequency of 4, because the lower limit and upper limit of the cumulative frequency of 4 is 1 to 4. So 12.5 does not exist there. But in the cumulative frequency of 18, the lower limit and upper limit here will be 5 to 18. So 12.5 is somewhere in between 18. So we'll be using this one. So Q1 is now highlighted by the blue color. Next is our Q2. Q2 is equals to 25. Now as you can see here also in the table, in the cumulative frequency, there is no number 25. So why didn't we use 24 in the cumulative frequency? Because 25 is much greater than 24, since the upper limit and lower limit of 24 is 19 to 24. So the data that we'll be using will be in the cumulative frequency of 29, since 25 belongs in the lower limit and upper limit of 25 to 29. Then now our Q2 is highlighted as green. Next for the Q3, which is 37.5. Same as the previous quartiles. 37.5 is nowhere to be found in between in the cumulative frequency, but it can be found in between the lower limit of 30 to 38. So we will be using the Q3 here, and it will be highlighted as yellow. Now that we have identified Q1 and Q2 and Q3, we can now solve for them. So solving for Q1. Q1 is equals to the lower boundary plus n over 4 minus less than cumulative frequency over the frequency of Q1 times the interval. So as you can see here, our lower boundary is 500.5 plus n is equals to 50 over 4 minus the less than cumulative frequency equals to 4. Now how did we get to 4? You just need to subtract the cumulative frequency by the frequency of the data. So 18 minus 14 equals to 4. That's how you get the less than cumulative frequency. Now, it's then divided by the frequency of Q1, which is 14, times the class interval of 50. Now, by solving this equation, we will get the answer of 530.87.51 or 530.86. Therefore, 25% of the workers are earning less than or equal to 530.86 daily. Next is we need to solve for Q2. So, same as Q1, we will be using the formula for Q2. Lower boundary plus 2 times n over 4 minus less than cumulative frequency over frequency of Q2 times the class interval. Now, our lower boundary is 600.5 times 2 times total frequency of 50 over 4 minus less than cumulative frequency, which is equals to 24, and we got that by subtracting 25 from 29. So the cumulative frequency minus the frequency equals to the less than cumulative frequency, which is 24, over the frequency of Q2, which is 5, multiplied by the class interval of 50. Now, Q2 is then equals to 610.5. Therefore, 50% of the workers are earning less than or equal to 610.5 pesos daily. Next is solving for Q3. Now, using the formula for Q3, lower boundary plus 3n over 4 minus the cumulative frequency over frequency of Q3 times the class interval. Now, based on the data given here, as we already identified it in the previous slides, the lower boundary of the data is 650.5 plus 3 times 50, which is the total frequency, over 4 minus the less than cumulative frequency, which is equals to 38 minus 9, which then equals to 29, all over the frequency at Q3, which is 9, times the class interval of 50, which then gives us the answer of Q3 is equals to 697.72. Therefore, 75% of the workers are earning less than or equal to 697.72 pesos daily. Now, for step 6, we need to solve for the interquartile range. So, I didn't give you the formula for the interquartile range, but now I'm giving it to you. So the formula for getting the interquartile range is very simple. It's just Q3 minus Q1. So now we already know what is Q3 and Q1. We can solve for the interquartile range. Now, interquartile range is equals to Q3, which is 697.72, minus Q1, which is equals to 530.86. So our interquartile range is now equal to 166.86. Okay, so that will be the end of our lesson for today. I hope that you've got something for our lesson, and you already know how to compute for the quartile 1, 2, and 3 by using the formulas being shown here. Okay, so for you to master this lesson, here are some practice problems that you can try to practice on your free time. Okay, so that is all. Thank you for listening, and goodbye.